Good afternoon, everyone. Welcome to a webinar, AI Applications in Actuarial Science. Today, we have two main parts in today's webinar. One on the application into the climate change risk quantification. This is one of the very important aspects which actually entire actuarial world is working because it has impact on every aspect of insurance, both life and non-life, where this part of it can be accomplished by applying AI tools very intensely as part of this particular project. And followed by that, we have the second one, that is issuing a policy using AI agents. That is another very important aspect of insurance business where actuarial science aspects are heavily involved. So both the parts are actually real ones from that point of view, means these are the ones actually which are working models, which we have created for the purpose of training all our students and the new employees, aspiring actuaries from that point of view. So as AI is actually impacting every aspect of every business, actuaries are also positively impacted from that. So we are looking at this as a opportunity for learning and sharing. So with that, I hand over this to Dr. Rohan Eshraj Gupta for his introduction and the importance of AI applications in actuarial science. Then followed by, we have Ishwar Prem. He is currently doing research in climate risk quantification. So he is going to speak about that. And the second part of the demo and presentation is going to be demonstrated by Hemant Sai Pawan and Ram Sai. So both of them, they worked on AI agents part, and then they will demonstrate the thing. And at the end of each part, you are free to ask questions, and then we'll try to accomplish that. And then if there are any further questions are there, you can ask at the end of both the presentations also, or any other questions if you have, feel free to type in the chat. Over to you, Dr. Rohan.
Yeah. Hi. Good morning. Good afternoon, everybody. It's really nice to see all of you joining today on the day of Ugadi, right? I'm sure it must be very busy at your homes, but still you made time for this webinar, which speaks for itself, right? Your interest in the field. But before
And
we
sharing.
begin, I'd like to very quickly introduce myself. I am Rohan. I am a PhD and a qualified GI actuary with over close to 8 years of experience in the industry. And I mainly focus on pricing, data model validation, predictive modeling, and so on. So I have been working very closely with insurance raters, testing frameworks, especially in the more modern cloud-based environments. Over time, I have been exploring how AI can be applied to solve practical actuarial problems, particularly in areas like automation, model enhancements, improving workflow efficiency, and so on. Right. And now coming to today's topic, right? So as actuaries, so we work at the intersection of data, risk, and decision making, right? But the scale and complexity of the data today is increasing very rapidly. This is where AI becomes very relevant. So why I'm saying that is because AI is not replacing actual judgment, like how general misconvention is, but rather what it is doing is it's helping us to make faster and better decisions, which is what we'll see in due course over the next 1 hour or so. What it can help you do is AI, it can help you analyze large and unstructured data set, which otherwise is very challenging. It helps you improve pricing and reserving models. It helps you detect patterns, which is very difficult to manually identify. It also helps you automate some of the repetitive tasks. So in this session, as sir mentioned, so we will be exploring some of the practical AI use cases across a couple of use cases which we have been working on over the last couple of months. So as you go through it, what we would like is we would like you to think about where in your current work can do you see AI can save time or improve the outcomes, right? So with that brief introduction, let's get started. And yeah, over to you, Ishwar, for the use case presentation on climate risk. Thank you.
Hi everyone, I'll first present screen. Is my screen visible?
Yes.
Yes, yes.
Yeah. So good morning everyone. So I'm Ishwar Prem. I'm currently doing my research in the field of climate risk and with more focus on quantification of climate risk. So today's presentation is titled as Quantifying Climate Risk and Revolutionizing Risk Rating with Geospatial AI. So this is a very non-traditional way of looking at the AI aspect, because we are trying to think when we say AI, it is only LLMs and large language models or chat GPT or Claude, etc. But essentially, when we say AI, as Rohan brother put it very nicely, essentially, when we say AI, the essence is being able to get insights from huge amounts of data. So when we say climate, it is we are dealing with terabytes of data usually. So until now, we did not have enough compute power to actually get good insight from this level of data. So with the AI and machine learning evolving in the last decade, in the last 4 or 5 years, so many new tools came up to handle this kind of climate data at scale. So we have used such latest tools to do some quantification of risk at a property level. So I'll dive deep as we go. So firstly, here I would like to address a question, why should actuaries worry about climate? We might think it is somebody else's task. So if we go by the definition of what an actuary is, essentially actuary is somebody who measures, manages and mitigates the risk. So nobody tells about pricing or reserving or capital modeling this. The core definition is measure, manage and mitigate the risk. So let us say if we take 100 years ago, there are no vehicles as such, or 150 years ago, there were no cars or buses or anything as such. So that time there was no motor insurance or auto insurance. But actuaries took it upon themselves to actually quantify the risk for auto insurance, and now it is a very common thing. Similarly, climate is a new upcoming thing that is actually causing a lot of risk. So it is our duty to actually quantify it in a meaningful way. And another aspect is, so the broad overview is, we'll first see why climate risk matters to actuaries, then how do we quantify using a framework, then we applied this framework for flood risk. So the main aspect is, until now climate change has been discussed as whether it happened or not happened or will it happen. But we crossed that stage. Climate change happened. So the only thing that we can do is, how do we deal with it? So first, to settle the misconceptions and to ensure everybody was on the same page, I made a simplistic definition of what is climate change for our context. So when we say weather, it is current state of atmosphere. So it could be 1 day, 2 day, or 1 week at the max. But when we say climate, it is a distribution of the weather at a single place over a long period of time. So it is essentially distribution of weather. So when we say climate change, it is essentially shift in the distribution of the weather. So if you see on the right side graph, we can clearly see there is a shift towards the rightwards. Now, as actuaries and for an insurance sector, we are not worried about the average part. So if the average temperature in a place goes from 35 to 37, that may not cause so much damage. We are worried about the extremes. That is what actually causes the losses. So if we see in the last few years or few decades, the number of extreme events and the frequency and impact of these events has been consistently increasing so much across the globe. There is no place that is isolated in this context. So now, as an actuary, we always go to the first principles of how we deal with a problem and look at a problem. So we have this famous actuarial control cycle. So if we take from those risk principles, the first step is identify the context. So in our case, the context is climate change. So we understood what is a context and we identified that is a problem. Then we describe the system. So climate change is causing the problem, but what problem exactly? So when we say climate risk, we classify it into three broad items: physical risk, transition risk, and liability risk. Physical risk is essentially the physical damage to property, whether it could be buildings or vehicles or any other thing. Transition risk is basically when somebody is doing business using crude oil or oil-based business. Suddenly there is a green revolution, green energy revolution, and they'll be out of business. So if they have to transition to a clean energy, they might lose the business. That is transition risk. Liability risk is essentially some factory or some industry caused pollution, and because of which, let us say, some people got affected. They can charge a lawsuit against this company because of whom they got affected. So, but in our case, we focused on handling physical risk because that is where we'll be using the climate and geospatial data. And to be more precise, we are focusing on the measuring the risk part. So when we say measure the risk, there are three broad components. So risk can be classified as three parts: the hazard, that is the danger part, then the exposure, then vulnerability. So I'll just go a little deep into what they mean. Hazard is basically, so we did for flood. So I'll explain you with that example. Hazard is essentially, will the flood occur on a given date or a given time? Exposure is your property exposed to that particular area or that particular danger zone? Vulnerabilities, okay, let us say you are in that zone, but are you still vulnerable? Maybe you have taken good measures by constructing flood walls or strong gates, so maybe you are not vulnerable so much. So only when we combine all these three, we get a good risk score. So this is a broad framework that we devise. So the first aspect is the data. So we need to be very careful of which data and how we are using, because if the data is wrong, our insights will be wrong. So the first aspect is data. Then we used machine learning based methodology. Then using that, we calculated the risk score. Then we briefly tell you about how this score can be actually used in pricing and reserving process. So now, if you see the down Venn diagram, that is a good indication of how we need to handle this climate risk. So climate risk is not an independent thing that actuaries can deal alone. It is a data problem, it is a climate problem, and a risk or actuarial problem at once. So we need to work at the intersection of all these three. So we need to collaborate with climate scientists and data scientists to actually make something valuable. So coming to the data aspect, until now, when we looked at the entire insurance industry, it was always looking backward. So we'll always look at past trends and try to extrapolate it to the future. But in the case of climate, all the past data is invalid because this kind of climate was not existing even 10, 20 years ago. So we need to always look at both historical and forward-looking data. So for that aspect, we took climate models data, which are called as global climate models, which will look even 100, 200 years into the future. So to cover the hazard part, we took climate data and past peril data. And to cover the exposure and vulnerability part, we took the geospatial data. So coming to the methodology, we applied machine learning because it is solving multiple problems for us. So there is data scarcity, whereas in machine learning, I can use data from multiple sources. Then machine learning or deep learning is very good at identifying patterns. It also takes less computation compared to traditional ways of doing it. And it is also flexible. It is not a rigid framework. Depending on the use case, we can modify it. And it is scalable. I can do it for a very small region or at a global level. So this is the crux of how we did it. So we took the hazard, exposure, and vulnerability related variables from multiple data sources, and we calculated the climate risk score. So for example, in the case of flood, we took temperature, precipitation for hazard, then the building footprint location and distance to water body as exposure, and the elevation as a vulnerability score. So how do we use this score in actually underwriting or pricing? This score can be used to classify the buildings in different risk tiers or classes, and accordingly we can do different prices for them. So we focused on flood because flood is globally the most devastating natural disaster. So we built a tool. First, I'll be showing you the entire tool of what it does, a demonstration. Then I'll explain how we built it. So here we can choose any date, and we built focused for Patna region. So we'll be going to Patna location. So here if we see, it is now telling processing satellite data. So when it is saying processing satellite data, essentially we are getting the climate data and geospatial data from different data sources in cloud on a live basis. It is not pre-stored data. So now I select another location very near to the building, I'll get a different score. So this way I can do for almost 150 years of timeline. So if you see here, I did for 2030. Then we can see even for 2050 we were able to do. So for different buildings in the same area, I'm getting a different score. So now I'll tell you how exactly we built it. So first, the climate data. So this picture might look complex, but I'll just simplify. You can think of it as multiple possibilities. So there might be a possibility where we transition more into green energy, which is a good scenario, and emissions come down. As a result, global warming will reduce. Or there might be a scenario where everything is increasing and we are not going back on using crude oil. So these are multiple scenarios. So you can tell SSP 2 as a good scenario, SSP 5 as a bad scenario for simple understanding. Then coming to the geospatial data, this is where our key innovation lies. So to understand geospatial data in simple terms, it is essentially taking the entire globe and dividing it into grid. It's almost like overlaying an Excel sheet over the globe. Then every grid is like a address point. So at that location, I can store multiple layers of data. I can store data about the elevation, about the streets, about the people, any kind of data. So now coming to what exactly we were trying to innovate here. Earlier, if you see the way address was taken, it was mailbox location was taken as the key address. Then they went to zip code level. Then they told, okay, single point for the entire building. The building might be spread over in, let us say, half an acre, but only one point conveys the entire address, which might be wrong. But with using AI and deep learning, now we are able to actually get the outline of the entire building. So I'll show you what we did. So first we took a Patna region. So how we did this? We used satellite imagery, and in Google Earth, we were able to actually get the outline based on the satellite imagery. Once we selected this region, then using deep learning based data set, which is built by Google. So they used deep learning to actually get the outlines of billions of buildings. So we were able to extract the data for this particular region. So if you see the entire district, whatever buildings were there, every single building is mapped. So this is a zoomed in picture on the right side. So the next step was getting the flood data. So what we did, we took last 20 years of flooding events. For each flooding event, let us say on 20th July 2002, one flood occurred. So we go to the satellite image of 20th July 2002 and label each pixel as flooded or not flooded using satellite imagery. which is again done using deep learning. Once we get that, we see if the buildings are intersected with that flood or not. So if we clearly see earlier, the entire buildings in one area would have been marked as flooded because there is no data, no detailed data. Now we can see even in adjacent buildings, some buildings are flooded, some buildings are not. And some buildings are half flooded and half not flooded. So it gives us a very clear picture of which building exactly was flooded or not. Based on this, we labeled our data as for every individual building as flooded or not flooded. So this is the overview of the data we used. So using all these data sources, we derived multiple metrics. It was not a direct derivation. We had to derive it from the required metric from the raw data. So using that, we trained an ML model based on flood occurrence. So if we see the performance of the different ML models, we could clearly see XGBoost and tree-based boosting algorithms performed better, mostly because of the non-linear patterns in the data. So when we use linear regression or logistic, it is usually linear patterns that are recognized. Here the data is so vast and so varied, the pattern is not captured by linear models. So we had to use tree-based and boosting algorithms. So the key takeaways are here. First is we are able to use publicly available climate and geospatial data. And then we were able to do it at a individual level, which will help us to label each building individually. So there might be in the same area two houses. One house is taking all the safety measures and constructed in a safer location, whereas another house might be constructed in a low-lying location in the same area. We can price at an individual level with very good customization. Thank you.
Yeah, that's perfect. Ishwar, very nice. The demo part, it is shown for Patna district, but it can be done for any part of the world. And also it can go 100 years into the future and 50 years into the back. The total range, it covers 150 years on both the sides. So yeah, it's open for questions now. Anyone has any questions on how this terabytes of data is used for getting the predictive part of the particular location, that Google Earth part of it, how it gets integrated with the actuarial techniques for quantification, So all those things are embedded in as part of this particular demo and the presentation. Yeah, feel free to ask if you have any questions.
Hi.
Yeah,
Nitya,
hi,
ma'am.
ma'am.
Yes, sir.
Yeah, please go ahead, Nitya, madam.
Hi, this is Nitya.
Hi, ma'am.
Hi. Your presentation is very nice. I'm really inspired of you. You're showing some demo. It is very really nice. You are predicting for nearly more than 2030, 2050. Was very nearly nice. I have only one question. You have chosen nearly 5 algorithms in machine learning. What is the
Correct.
reason you are choosing only 5 algorithms? And what is the reason gradient boosted algorithms a better algorithm you're choosing? You're telling like here.
Yeah. So this was more of a proof of concept that we built. So we are actually doing more research on which other algorithms can be used or can we use more recent algorithms. So this was just to convey that it is a possible thing. And I was also running it on my local machine. So I could not run more complex algorithms, which will actually require a GPU. So I built this entire thing only in my laptop. So once we are currently still working more on which algorithms to use at every stage. So then we'll improvise it.
Can you tell me what is light GBM and CAD boost? I don't know. That's why I'm asking you.
So essentially, boosting is a method where first we build one tree and we predict it. Then instead of rebuilding another tree, we take what is okay. Let us say my prediction is 10, actual value is 10, I predicted it as 6.5. So in boosting, what I do is I build another tree to correct the error part. So the error was 3.5. I'll try to reduce that error to, let us say, 3 by building another tree. So I keep building more and more trees to reduce the error part instead of rebuilding from scratch. So this XT boost, CAT boost, light GBM, these are essentially multiple variations of this boosting algorithms. So the core concept is boosting. Using that, ML researchers built multiple versions which are like light GBM is called light because it can run with lesser computation. So these are just variations of the same concept.
Yeah. Thank you so much. Thank you.
Yeah.
Jashwant, you had a question.
Saram, actually good presentation. Uh, actually, I'm not good at technical stuff, but you've mentioned that before and afterwards happening of event, you were able to get the data of an event happening before and afterwards. Can you tell me like how did you predict that data and how are you able to integrate into the model?
Okay. So for this, very good question actually. So
If you could repeat the
I'll take
question, right? Ishwar, it was not audible. Please repeat the question and then answer.
okay. So he was asking, how did I actually get the climate data and integrate into the full process, and especially the future data? How was I able to get the future climate data? So the answer lies in this question. So we are working on the actuarial and data science aspect of it. So the climate data is actually built by climate scientists. So these data are essentially a simulation of future. So they build it using supercomputers. We can't do it in our local systems. So they replicate the real life scenarios of how the Earth's atmosphere functions, and they build multiple possible scenarios. So that data is available for free in their databases. We need to appropriately download or give access to the appropriate data set in the cloud and use that.
Yes. Bro, and you also mentioned that the future data we might not know what will happen in the future. Like the event which is happening today might not happen tomorrow. Like you run all the time.
So,
Like,
so the answer here is in especially climate science. There is no right answer. There is no right model. We can only have data and models which are useful to get some insight. So there might be hundreds of scenarios. We need to use our actuarial judgment to actually see which models are relevant and which ones to use, and try out multiple experiments. It is not like a single answer of yes or no. It is more of 50% correct, 60% correct kind of scenarios.
Yeah, and also just to add on that, so generally whenever we do any kind of predictive modeling, right, there is an underlying assumption that past is representative of the future. So what it means is, whatever data you are using to predict the future, there is an assumption that okay, whatever happened in the past, a similar trend will follow in the future. So any one-off scenarios or anything like that, you may not be able to predict, right? But what we can do is when we are doing specifically when we are doing things like climate modeling and all. So Ishwar had presented a slide in which he showcased various kind of scenarios, right? So in the climate risk analysis, so globally there are some standards of assumptions which people do to model. So those assumptions, so these assumptions which are classified under various categories, probably Ishwar can elaborate on that. But the idea is there is one thing where you are using the past data, and then on top of that, we are also enhancing our predictive modeling using some of the scenarios, which is fairly standard globally by all the climate risk modelers. So yeah, that's one thing which we need to keep in mind.
thank you.
And just to add that, bro, so you rightly mentioned it is a standardized data. So the data that we used is not some random data. It is actually released by the United Nations every year. So we used the latest data released by them to model our thing.
Yep, that's excellent. So any more questions from anyone else?
Saram Ishwar, thanks for the presentation. I just have one question, Saram. Yeah, like what kind of products can we sell? Like, what kind of products are we targeting it uh, as an insurance company, and who will be our stakeholders?
Yeah. So we are mostly it is property related insurance. So our stakeholder will be the insurance company or the underwriters who actually evaluate the risk. So if a new customer comes in and he tells, I need a property insurance, this is my location. Without asking him more details, you can actually on the spot get a risk profile of his particular property. So that will help us do better underwriting, which will help us in actually avoiding scenarios where we keep getting bad customers. So in this way, over a period of time, our entire customer base will be on a positive side.
Okay, understood. Thank you.
Yeah, that's a nice issue. So shall we move on to the second part of the webinar? Yeah,
Yes.
please. So yeah, Hemant and Ramsai, over to you. So we'll get into the policy issue using AI agents. This is something actually very interesting. AI agents are actually being used extensively in every industry, and this is a very good proof of concept which they brought in. And yeah, over to you. Get into the policy issue
Yes.
using
Thank you,
AI
sir. Let me first share my screen.
are actually being used.
I hope my screen is visible.
Yes, it's visible. Yeah, just little louder your voice. That will help.
Okay. Is it good now, sir?
Yeah, perfect.
Okay. Good afternoon. Thank you all for your time. And I hope everybody enjoyed the first part of the session by Ishwar. Today, I will be giving you a quick demonstration of Prime Policy, our agentic AI-based policy administration system, which is basically a web-based application designed to simplify how organizations view and manage policy-related information. And this is a conceptual demo focused on showing how the experience would feel like for a business user rather than the technical and implementation details. Now, what is the problem statement? In many organizations, even today as we speak, policies and decisions are scattered across emails, multiple documents, multiple systems and servers. And this creates three major challenges: the time that is wasted in searching for information, lack of clarity, and slower decision making at the leadership level. Prime Policy addresses this by offering a simple interface where the policy information can be accessed and understood quickly. Now, where this agentic AI solves the problem, and what is the introduction for agentic AI? What is agentic AI? In a very simple definition, agentic AI is an AI that doesn't just answer the questions, it can take actions to achieve a specific goal. Now, if we understand the statement properly, agentic AI is an AI that doesn't just answer the questions. Now, what is the kind of AI that just answers the questions? It is generative AI. Now, what is agentic AI? Agentic AI is one step after the generative AI, which also takes actions and achieves a specific goal. That is AI agent. Now, what is agentic AI? Agentic AI is one step after the AI agent. Agentic AI is basically an ecosystem of AI agents all those individual AI agents working together to achieve a specific goal after a process, after a pipeline. At its core, Prime Policy is a centralized policy visibility platform. It is designed for business managers, decision makers, operational teams, whoever needs fast access to reliable information without any complexity. Now, I'll let Hemant present the screen of the platform and walk you guys through how a typical user would experience the platform.
Yes. Hope you are able to see my screen.
Yes.
Yes, Hemant.
Great. So this is the landing page of the web application. So we are trying to reimagine how a policy is issued and how the life cycle of a policy goes on until it's matured or claimed. So we are specifically focusing on underwriting decision in this particular POC. So if we have a look at the architecture, as Ramsai very nicely put, the current workflow is very manual, time-taking, and very, like, you may say, inconsistent because of various people having various different views on things, especially when it comes to underwriting. So this particular web application will help read the policy documents and also extract information from that documents and give a decision that whether this policy is a high risk profile, low risk profile, etc., so that the underwriter can also come in at the end and give the final decision whether to accept this particular policy or not. So since we would not want anybody or anyone to get access to the data, we have the authorization. Only authorized people can authenticate themselves and log into the page where they'll be landing in this dashboard page where the underwriter. So I'm wearing the hat of an underwriter here. So you can see the various active policies that are there in the system. What are the number of policies that are processed? What is the time taken? Are there any system errors that can be seen here? And we have the option of creating a new policy here. So we have broken it down into 6 different steps, 6 unique steps where a policy is created. So yeah.
Once we have the new policy issuance request from the user to the underwriting team, the first AI agent accepts the request and gets all the relevant information about the policy holder. All the basic details like the name, occupation, the email address, annual income, which are all part of the application itself. Can you once scroll down, Hemant, to the next step? And then we have the document ingestion part, where all the policy related information is automatically fetched into the database by multiple agents and extract the information from the PDFs and clean the data and store all the information in the database. And then comes the next step in the pipeline, which is identifying the risk. Now that we have the information which is extracted from multiple PDFs and multiple sources, the AI agents need to flag the risk by cross-checking and comparing multiple files with respect to the financial documents and with respect to the medical related documents. And the AI agents will automatically highlight and flag the potential risks involved. And in the next step, we have the compliance team. Now this compliance team of AI agents do the sense check of is there any anomaly in having the nominee details? Is anywhere it is out, are any outliers identified in as part of the compliance check as for the anti-money laundry regulation or any policyholder protection regulation with respect to multiple IRDA regulations. And we have the compliance team of AI agents. And in the next step, we have pricing based on the risk factors which are identified by multiple AI agents. What would be the premium for a particular sum assured? For a particular sum assured based on the identified risk factors and the loadings, what would be the premium on different premium frequencies, monthly and annually? And in the final step, the issuance, underwriter will have the final decision to take based on the flags identified by the AI agents and also the premium which is basically computed by multiple AI agents in the final step. So the policy is issued, but the final review and the final decision will be by the underwriter. In this way, the information which is very hard to extract from multiple sources and validate and cross-check will be easy, and the identification of the risks involved in issuing a policy for a particular policy holder will be easy, and the time taken for an underwriter to come at a decision will be reduced. And after the 6 steps, which are automatically done by the AI agents, the policy queue will show the policy holders' decisions for the underwriter to finally come and take the final decision. The underwriter can just come to the system and go to the policy queue and review all the applications which are in pending, and the underwriter team can give the final decision for the policy to be issued or not.
So just to add here, so if you look at this entire thing, so each of the type of agents are actually doing activity normally done by a clerk or a human being. So what this agentic AI proof of concept is doing is bringing each of these agents to perform their job based on the orchestrator agent that is created there, and then making sure every aspect is done in a consistent way, in the most efficient way, and finally bringing everything to the in front of underwriter, so that the right decision is can be made by the underwriter at that point of time. So also the calculations that are required to make how much premium should be charged based on the risk factor, that also gets done as part of this particular agent's activity. So is the combination of all these things put together, it brings greater efficiency for the entire insurance organization. So it could be life, it could be non-life, but the way you can bring in lots of administrative work which is done from various other sources is actually brought together very efficiently by these things. So that way, actually, more and more applications can be processed, and then the underwriter can do a qualitative activity of judgment, what can be done. That's why we say the AI is not replacing people, but it is actually providing help for making an appropriate decision. Because the type of work which gets actually replaced is actually the routine common work, which actually now the agents are able to do it in a most consistent way. and in a very short span of time. So that is what is the business side of it. So which will help in this particular model. Okay. Yeah. So over to you, Ramsay, again. So,
Yeah,
please
just to
continue.
also quickly add on that part. So generally, whenever underwriter is notified of a particular policyholder, right, and then from that point of time till the time when the policy is issued, that entire process is a very time-taking process. So it can take several days to several weeks, also at times, depending on the complexity of the quote. Okay, but when you have a agentic AI system like the one which Hemant and Ramsay presented, what can happen is you can standardize the entire process. So it's when you have a system like this, an agentic AI policy system like this, so you can bring down that entire policy issue time from days and weeks to just minutes or even seconds in some cases, right? So that's what is the benefit. And also over and above that, the other important aspect which these systems help you bring is consistency, as sir also mentioned, right? Because whenever we are issuing policies, there is an aspect of underwriters going through the documents, understanding the risk, and then appropriately making a judgment as to where exactly that classifies, which then gets fed into how the premiums are calculated. But when you have a system like this, that entire logic of manual investigation can be offloaded to agentic AI systems. And as you can imagine, right, when you have the entire thing being offloaded to a system which you have coded, you have full control over how those assessments are happening, right? So there are lots of benefits. First, most important benefit is the time savings which you have. The second benefit which we see is the human error, the potential human error which can come because of this manual intervention. And then the third thing is this from the time when a policy is notified till the time when it is issued, that is a very important KPI, right, for any insurance company. So if you are able to reduce that time frame drastically, you are able to translate that into the actual quote at the end, right? So yeah, these are a couple of things. So the entire idea is using agentic AI systems. Some of the manual processes which is currently there in the insurance company are very rapidly being thought as to how they can be enhanced, and this is one such example which you are seeing today in the webinar. So yeah, what we would like you to do, as I mentioned earlier in the introduction as well, is that get a sense of how exactly the world is moving, what exactly is agentic AI, what are some of the potential use cases, with this being one, right? And then see how it can be used into your day-to-day work, in your day-to-day activities, whatever you are doing, and how it can be improved. So that is what the intention is. So yeah, with that, maybe over to you, back to you, Hemant and Ramsay.
Yes. Let us quickly recap the entire demonstration. Firstly, we have the traditional policy administration system. Now, what is policy administration system? It is basically a system which is capable of handling the policy lifecycle from beginning to the end, while the policy issuance request enters the system, and the end there might be some claim or the expiry of the policy. In between, the entire life cycle of the policy will be handled by the policy administration system. Now, AI agents and agentic AI, as we discussed, AI agents are basically the AI concept that doesn't just return the text or answer your question, but also takes actions by planning and taking the action to achieve a final goal. Now, what is agentic policy administration system? When we introduce the agentic AI ecosystem to a traditional policy administration system to automate multiple tasks at multiple phases for reducing the time and reducing the manual errors and the human dependency, that becomes the agentic policy administration system. We have the user authentication process, we have the user authentication and authorization process. User authentication is basically for allowing the person, allowing the basically giving the login ID for a particular person, and based on the login, we have to give the access. The underwriter team will have a separate access. The operational team will have a separate access. The role-based access will be given based on the authorization. And then we have the 6-step workflow. These can be multiple steps. For now, for this proof of concept, we have limited ourselves to the 6-step. First, we'll have the intake of the basic policyholder details, and then we have the document ingestion, which also has the text extraction and the semantic chunking and all the technical implementation of storing all the policy related information from those documents in a structured format inside a database within a schema which is predefined. And then we have the risk AI agents, which identify potential risks from the text that is extracted from multiple documents. And then we have the compliance team, which checks with the regulations of the IRDI and see the compliance. And then comes the pricing agents, which helps the underwriter team to arrive at a dynamic premium number with the built-in premium calculation with the risk identified and the loadings, and then the final issuance by the underwriter team. With this, we end the demo and we can have a quick question and answer session.
Sarah, hello. Am I audible?
Yes.
Yeah.
Yes, Sairam.
So this was a very informative presentation on policy administration. My question was that on what note does the underwriter accept or validate the policies, and like what is the crucial human decision to be involved in here?
So the decision is at the end by the underwriter. So the agents are extracting information, whether it is medical, financial, or demographic. Let's say he's coming from a particular region where it is more risky, or he's coming from a profession that is more risky, or he has some hobbies or adventures that are more risky, and all those things. Are there any medical conditions that he's already indicating through his medical reports, or he's a smoker, non-smoker? All these things are being extracted, and that information is used by the agent to give a decision on whether it is a standard life or preferred, whether the policy should be agreed to what percentage and all that. So with all the information, all this information gathered, the underwriter will take the person takes the decision at the end whether to accept it or not.
Yes, and also on top of that, there is one very important aspect where the humans also get involved, especially actuaries, are the aspect of risk appetite, whether the insurance company has the appetite for the risk which it is writing or not. That is one very important thing where the actuaries have to come in. And this system, what it does is this system, while it generates a policy for you, it won't really issue the policy on underwriter's behalf, right? So the underwriter will essentially have to come into the system at the end stage of the entire policy issue workflow, which you saw, and then only a human can finally trigger whether this has to be issued to the ultimate potential customer or not, right? And over and above that, the agentic AI systems also flags various aspects where it needs humans attention. So you had seen in step 4, I believe, where there was an aspect of risk assessment, right? So in the aspect of risk assessment, it will highlight to you whether the particular thing, are we seeing anything unusual or not with the particular health documentation or any medical documentation that needs attention and things like that, right? So yeah, there are appropriate checks in place where the agentic AI systems require humans to get involved and then provide its sign off before ultimately the policies are being issued. So yeah, we have those checks in place, and in all of those checks is where the human involvement are required. Hope that clarifies.
Yes, sir. Thank you.
Yeah, Nitya, madam, you raised your
Uh,
hand.
yeah, sir. Uh, Thanks for your presentation, sir. I have only one doubt. Basically, I'm working on a health insurance. Most of the policyholder they are submitting a documents are fake. For example, suppose if any person having any chronic disease, they are not submitting the proper documents. So in the process, the most of the insurance company facing a loss of claims loss. How we have to manage those things, sir?
Yes, so that's a very valid point, madam. So what we do is, so there are checks in place. So wherever our system finds any anomaly, any anomaly in the reports or anything, and follow up request will be sent to the potential customer, saying that saying to asking them to provide an additional documentation to support whatever it is that they are stating their health state is at. So yeah, there are various checks. If the system identifies that, okay, this is potentially being fabricated, then a follow-up question will be asked for providing further evidence. That's one way in
Yeah,
which we mitigate.
yeah. Just to
Sir,
add here,
one of
just to
the
add here.
opponent, he created every documents fake, everything. Finally, he get a claim also. It is possible, sir.
Yeah. So here, no, there are multiple algorithms we need to run, right? See, if fraud detection itself is a huge area. Actually, Dr. Rohan Yashraj's his PhD is on fraud detection in motor and health. Hmm. So we did work on that. So it is possible, right? To just answer, it is possible. Just that actually we need to have these checks and balances on multiple things. One is the supporting documents which are provided, the validation of that. Okay, then because some of these things they're created on separate way, and then there is a way one can easily find out inconsistencies in that, and then flag it. That is one way of doing things. But again, nothing is foolproof. Again, one more method of doing fraud comes into play. But like the algorithms normally, what fraud detection algorithms, they are actually, they keep learning based on this. But normally it's not just for the health insurance industry. It is for multiple things. Particularly for health, it is more prone because people want to quick support their people without paying huge premiums, and also hide things. There is a moral hazard aspect of it. So there's a huge element of fraud in health insurance, even in advanced countries. So these tools, AI tools, are excellent in identifying things, newer types of frauds also. So a separate method is adopted. Like we used something called fraud classifier as part of our previous research thing, which we presented, and then also published a paper with the CAS. If you look at that, okay. So, and also the AI will be more handy in identifying such things. So while doing the fraud detection, again, we are concerned about uh, false positives. That means actually somebody has not done fraud, but like we flag them as fraud and then investigate, then we may lose the customer altogether, So that is where this is a balanced activity which gets done. So there are definitely multiple tools available in the market, but each company gets a different types of frauds based on the process they adapt. Yeah, so we can fine tune our algorithms to that and then identify the type of fraud which you are mentioning, Nitya madam.
Thank you so much, sir.
Thank you, madam. Rohan, do you want to add anything on this?
No, sir. I guess yeah, that's a fair thing. So fraud detection in itself, right? So that's a area. So where lots of newer models are currently being incorporated, like with agentic AI and then LLM models that we have. The level of what do we say, the analytics which we can do, right, is humongous. So yeah, those also have to be looked into.
So perfect. Any more questions from anyone? Yeah. So that's great. So we come to conclusion of this webinar. It's very positive that many of you attended and actively asked questions. And this is a real application of AI into actuarial work. So we thought actually we bring it up to each one of you, and then we take it to the colleges and those who are working on this, so that there's a great opportunity which actually you can bring in as we move forward. So we thank all the participants. We thank all the presenters, particularly the climate part of risk quantification by Ishwar Prem, and followed by the presentation on policy issue from Hemant, Sai Pavan, and Ramsai Jagdish. So that was an excellent presentation. Thank you, Rohan, for adding for the additional inputs into this. So we will keep having some of these newer insights of AI applications into actuarial science. And we are also planning to have a summer course program in the month of April and May, which actually will be available to all the students. Entire education aspect of our SSSIA Institute of Actuaries is free. We will make it available to all the students across the country so that the profession can grow in that direction. So please encourage your students to join us at any point of time in the future webinars. The summer course program also is going to be open. We'll be communicating to everyone. And we will also have internships coming up from our side. And we will also have the health side, Nitya Madam, that is also there, because on health side, we worked on Ayushman Bharat, which is the world's largest group health scheme. So that also we'll have pretty soon. So these webinars we'll try to do every month. That way, actually, it will cover and it will give opportunity for students to take it up. So upcoming, we have summer course, we have internships for all the college students. So that way, actually, all students can get the benefit, and they can also work in the newer areas of AI and actuarial data science applications in this. Thank you very much. With this, we close today's webinar.